Lesson 13, Optimizing and Tuning Data Guard Configuration. In this lesson, we will discuss about monitoring configuration performance and how to optimize read transport service for best performance, and how to optimize SQL apply, and also tunable automatic outage resolution related parameters, and also diagnostic tools available to diagnose standby database workload. Okay, so first of all, you can actually monitor performance of primary database and standby database, especially redo transfer service and redo apply service available through Data Guard performance page in Enterprise Manager. In the Data Guard performance page, you will see overview information, and also in this particular example, what is a transport lag and what is applied lag. So you will see lagging information and also apply rate information as well. So you can actually monitor performance of a redo transport service and redo apply service, and you can also check whether redo generation rate is balanced with the redo apply rate. So that's one thing what you can use. I'm going to show you Enterprise Manager to give you an example of a Data Guard performance page. Okay, so I'm in the Boston database, which is a primary database, and you can go to Data Guard performance page under availability menu. So you have a primary database, which is a Boston database, and you also have a London database, and also you see the redo generation rate, and also you have a lagging information, and you have apply rate as well. For this demonstration, what I'm going to do, I'm going to actually run test application just for about 5 minutes, and then I will show you the performance information, especially redo transport service performance, redo apply service performance. So what I'm going to do, under test application, I can start test application, so it will generate workload, so we can watch the progress. So starting test application. So what I'm going to do, I will post this recording, and then after waiting for 5 minutes, and I will come back to see result. Okay, so I waited a couple of minutes, but it doesn't seem to generate load, so I couldn't show you the example. But actually, this is a page where you can see redo generation rate and also redo apply rate. So this can give you good information about performance of the redo generation rate and transport lag and apply lag, and also some other information available here. So let's come back to slide. Okay, so if you see the performance issue in the reader transport service area, we can apply a couple of techniques. First thing is setting net timeout database property. And also you can try with the Data Guard sync latency database property. And also you can try with the redo transport compression as well. So net timeout is the maximum the number of seconds which primary database can wait. Okay, if a communication between primary and standby database exceed exceed the net timeout, then the standby database will be considered as failed destination or inaccessible destination. And then how often we retry to connect to failed destination? We can actually set reopen second. So it's a minimum number of seconds before archive process try to access previously failed destination. So if you want to check destination status more frequently, you can actually set equals to lower value. Or if you want to check the status of a previously failed destination every 10 minutes, just like an example here, you can set it to 600 seconds. So that that can be controlled. And also in your given network configuration, what is accepted network latency and delay. So we can actually, in this case, net timeout, by default, we can wait for 30 seconds, okay, as long as members of a data guard configuration can communicate within 30 seconds, then we will consider all members are available in the data guard environment. However, if a standby database is not reachable or doesn't respond over net timeout, and that is the time when the destination becomes failed destination. So we can actually control the net timeout, and also we can control frequency of checking the previously failed destination. And another thing is, we do have data guard synchronous latency. Suppose that in your environment, you configured maximum availability data protection and or maximum protection. So in that case, if you have more than one standby databases, the idea is, let's say in the primary database, you issue the transaction and you issue the commit statement. And the primary database, it waits acknowledgement from synchronous standby databases. Okay. If a standby database doesn't respond within the timeout, then destination will be marked as the failed destination. So let's say in 1 second, the first standby database is send the message back. However, in a second standby database, it doesn't respond immediately, and after waiting 29 seconds, and then eventually it sends the message. Okay, so second destination is still available destination, but you may want to configure your data guard environment like this. No, that doesn't work. After first standby database send acknowledgement back to primary database, and I will wait maximum 5 seconds, okay, expecting second standby database send the acknowledgement within 5 seconds instead of waiting for 30 seconds. So you can specify data guard sync latency. Okay, right after first standby synchronous standby database send the acknowledgement, then how long you want to wait for second standby database feedback. Okay, do you want to wait up through 30 seconds, or right after standby database send the message back and you wait only 5 more seconds, okay, for the second synchronous standby database? So you can control this. Okay, so we don't have to wait up through 30 seconds. So that's another possible configuration. Here we have another way to optimize a redo transmission, especially in case of a network outage. Suppose that we had a network outage for 30 minutes. So standby database is behind. So in order to resolve a redo gap, either either the reader transfer service or reader apply service or SQL apply service request the missing redo. So if the amount of data that must be transported to a standby database is huge, it may take some time. So in order to reduce, we can enable reader transport compression. By doing so, all missing redo will be transported in the compressed format, so we can save bandwidth, and also we can transport less amount of data. So we can enable redo transport compression feature. So to use this feature, you can change it, redo compression equals to enable. Okay, or in the SQL prompt, you can use alter system set log archive dest service equals to London sync compression. So either data guard broker command line interface or SQL prompt, you can enable read compression. So that's what you can do. If you want to confirm from $, archive destination, it will show you compression status, whether you enabled read compression to certain destinations. And another possible configuration, we can configure delay of application redo. That's a possible thing. But this is not commonly used these days, but it's a possible thing. So for example, if you run your transactions in the primary database and redo transport is to standby database, instead of applying redo immediately, you may want to set up application of a redo delay, so that way your standby database is a few seconds behind, few minutes behind. Wait a minute, why do you want to delay the application of a redo? If you have a multiple standby database in the data guard environment, and you can set up application of a redo delay in the first standby database 2 minutes, second standby database 5 minutes, and third standby database 10 minutes, and so on. So if you make any logical error in the primary database, we can search for standby database that doesn't include this logical error. And then we can do a failover operation and switchover operation, failover operation as well. But these days, we have a better option, flashback option. So you can flashback primary database, and you can synchronize standby database easily. In 19C, we have an automatic solution as well, and which we're going to discuss later on. But if you still use this feature, you can also use, you can change it, delay min equals to 5. So you can actually delay application of redo for 5 minutes. So that's one thing what you can do. And also you can change it, redo apply delay through Enterprise Manager. By default, it's 0, meaning that we apply redo as soon as the redo is available in the standby database. So real-time apply is default behavior. Now let's take a look at logical standby database. In the logical standby database, we learned that there are a group of processes work together to synchronize standby database. For example, once the redo is received and stored in standby redo log file, preparer process, actually reader process, is responsible to scan redo in the standby redo log file. And this redo entry must be converted to LCR form, logical change record, that describes change to each row. And then the builder process is responsible to group LCRs as one transaction. And we also have an analyzer process that is responsible to check dependency among the transactions. And then coordinator assign transactions based on dependency to applier process. All these processes work together, but out of these processes, two processes perform more work compared to other processes. One is a preparer process and the other one is applier processes. Preparer processes, it must convert redo form into LCR, logical change record, and also possibly it can also filter conditions as well, and also it can add it can enqueue the filtered the entries LCRs into memory. So it does a large amount of work. And also in the last stage of a SQL applier process, it executes actual SQL statement. So it does perform large amount of work as well. So based on performance of a SQL apply, you may want to start more preparer processes or more applier processes. Think about that. Your redo generation rate is very high, so 20 megabytes per second. And in the standby side, logical standby side, reader process can scan large amount of redo without without making any delay. However, preparer process, it must scan all 20 megabytes of redo per second, and then it must convert redo into LCR and also evaluate filter condition. So that takes a long time. So you can actually check status of a preparer process, and then you can make decision whether you need more preparer processes or not. And also apply process as well. You may want to apply changes in parallel instead of applying assigned transaction in serial. So you can also start applier processes based on status of applier process in the standby database. In order to change it, the number of prepare processes and also number of applier processes, we are going to use DBMS logical standby database package. And then we can change it, apply servers, max servers, and prepare servers. So before adjusting the number of applier processes, we will have to monitor first. So we determine whether adjusting number of applier processes achieves greater throughput. So you can check applier process, whether applier processes are busy or not. So we have a code number 16116. So we identify apply processes, whether apply processes are busy or not. And also you ensure that there is enough work available for additional applier processes. So that's also another thing what you have to check. And also you can adjust number of preparer processes. Same thing for preparer processes, and you check the same status code, and you're gonna check, you're gonna ensure that all preparer processes are busy. Meaning that, let's say you search for preparer process that is that is busy. So this this SQL statement should be returned 0, actually no row, meaning that there is no idle preparer process. If it returns the actual rows, that means you have idle preparer processes. So you have to check whether your preparer process is working busy, or if there are any the over allocated resource or not by executing this SQL statement. And also you can you ensure the number of transactions ready to be applied is less than the number of available applier processes. So you will have to balance the number of transactions and number of available applier processes as well. And you determine whether there are idle applier processes or not. So if it returns the list of entries, so we search for the applier processes, but if it returns many number of idle apply processes, you will have to adjust this back to lower value. Okay, so based on this query, you can increase the number of prepare processes, and also you can increase or decrease the number of the apply processes. Okay, so we have a tuning automatic outage resolution. DataGuard maintains internal mechanisms that detect and correct issues with its redo transport and gap resolution process. Think about that. The enterprise manager or DataGuard broker reported redo transport lag about 10 minutes. It could be because of network configuration failure or network outage, or it could be network delay. Okay, so it could be performance issue, it could be actual I/O issue, network I/O issue. So we have an internal mechanism that checks whether your performance issue, especially in the redo transport area, whether it is a network problem or disk I/O problem, okay, or it is actual performance issue because of a network latency and a round trip time. So since the DataGuard can maintain and also maintain internal mechanism, so DataGuard uses these two parameters: DataGuard max I/O time and also DataGuard max long I/O time. So if the waiting time waiting time exceeded your setting, then Oracle DataGuard will consider this as a hang issue. So Oracle DataGuard will try to fix this problem as a normal problem resolution. Okay. So it's kind of detecting internal issue, and this is not performance issue, but this is an I/O issue. So detect I/O related issue and fix the problem internally, just like any other I/O related problems. So we can actually resolve problem in case of outage, okay, in the normal way. So this is two possible parameters. Is this network performance issue or disk performance issue or actually hanging issue? So we can easily check, and internally this will be fixed. And diagnostic tools in active DataGuard standby databases. In active DataGuard standby database, we can offload the large amount of work, especially I/O and resource intensive work. So sometimes you may observe performance issue in the active DataGuard. Okay, so you may want to identify root cause of a problem. So for example, you offloaded a reporting query, you offloaded read mostly application, and you offloaded analytic queries. Okay, so you may want to check what caused the issue. So my reporting query ran fine without having any problem. From last night, suddenly performance degradation was observed. Why? So we can use various tools. You can use a standby stat pack, or memory version of an active session history, or you can use a real-time SQL monitoring tool, and also 10046 trace and 10053 trace, and also SQL T tool is available, SQL health check report, and system state dump, and also hang analyzer trace is possible. and also automatic workload repository for standby and ADDM is possible. I added just a list of diagnostic tools, and I created a practice activity about AWR for standby database, and also ADDM, and also SQL tuning advisor as well. And before getting to the area, let me show you one short demo. Okay, so I came back to demo environment. So in order to monitor performance of standby database, you can use Enterprise Manager, and you can directly access to standby database. In my case, I have a physical standby database, London 2. In the performance page, it gives you weight information and also user I/O. So this is the most common statistics. Even in a well-tuned environment, you will observe CPU and user I/O. But if you see a long wait in this color, then it probably is something else. So you can go to performance page, and then you can actually monitor your database activities through performance page. So in this case, just like a primary database, we have a 13 weight classes. So let me make this a little bigger. So in this case, you probably have a large amount of user I/O, because you can run analytic query and reporting query. Okay, so you can see this one. If your database is a rack standby database, you can also see cluster related statistics information as well. And you can view how many transactions are supported by physical standby database or logical standby database. What about I/O? So that's what you can see. And also, when you go to a performance page and top activity, if this were a primary database, this top activity, it shows active session history statistics. It gives us the most current the 1 hour worth of statistics. Okay, so you can actually move back and forth. And also, because we have historical data, so you should be able to use the history. However, as you can see in the physical standby database, you only have a few options: 15-second refresh and manual refresh, meaning that active session history is only available in memory for standby database. So active session history view and statistics, this is not possible through AWR. So in memory, active session history is available. So you can actually monitor the most current statistics, the most current activities through Enterprise Manager, and you can also review the SQL statement accordingly, and also sessions accordingly. Unlike primary database, you don't have option to create SQL tuning advisor task in the standby database. Okay, so I created the other way to create SQL tuning advisor for standby database in the practice activity. Let's actually run active session history report. So here I'm looking at current date and also 227, 232, and I will generate report. So after waiting a couple of seconds, so finally you have an active session history report for Boston DB name and London DB unique name. So this is for physical standby database. So as you can see, it is host 03. The source of this report is in memory. So that's why you have a $V view. So just like a way to analyze active session history report in the primary database, you can also review active session history for physical standby database. But what about this? I want to change it, this date. Let's say past date, so in this case 26, and also I will choose 26, and I will generate report. So can I generate active session history report for physical standby database by using AWR snapshot taken in the past? That's what we're going to test here. Okay, so finally I have a report. As you can see, it shows Boston DB unique name, and it's coming from host shadow 1. And also this is DBA history active session history. So as you can see, active session history, it is available for standby database. However, it's only for the memory statistics. So that's what you can see from this demonstration. But what about AWR report? So I have an AWR, and here AWR report. I'm in the physical standby database. So let's say I can choose snapshot. So I choose 425, and I can choose. Okay, this is the last one, so I better change this, cancel it. And 425, and generate report. So let's see if I can generate AWR report for London database. Okay, so I generated the report, but unfortunately this is the primary role. So Enterprise Manager, it doesn't give us a physical standby database, the AWR report. So what that means is you cannot run in ADDM against the statistics on physical standby database. So with the active data guard enabled. So we have the other way around to use AWR report. Thus we can use ADDM, and also we can use SQL tuning advisor based on physical standby database AWR snapshots. And that's what we're going to discuss. So I'm going to come back to the slide to discuss about this area. Okay, so this is an AWR Unified Management Framework, UMF topology. So what you can do is you can set up a target catalog. It could be your primary database, or it could be your AWR repository database. And then we can register source databases, which is the source of AWR data databases. And then we can actually receive AWR data, and we can save it in the target catalog database. Or target catalog database in the data guard environment, it could be primary database. Okay, so the step here is, first of all, you set up a database link. So from the catalog database, so AWR catalog database to the source database. And source of AWR, in our case, physical standby database, or the physical standby database, because it works only for active data guard. And also, database link must be available to the remote AWR data, actually the target catalog database. In our case, this catalog is created in the primary database, so primary database becomes AWR catalog database. So when you create database link here, then the database link will be propagated to a standby database. So standby database can communicate with catalog, which is primary database. So in our example, in our practice activity, I created this catalog in the primary database, and I also created a database link in the primary database to let standby database use it. So you define target database. So target database is a database that holds the AWR catalog, and then we're going to create a topology. The topology is a logical group of databases that can share AWR catalog database. And then we're going to register source database. In source database from AWR data perspective. So primary is a source database, and standby is a source database. And also your primary also database that keeps AWR catalog as well in our practice environment. So we can set up this way. So I'm going to show you a quick review of a practice activity. Okay, so here's your practice 13-2. It is to show you configuration of a remote management framework or unified management framework. Okay, so this is to use AWR report, AWR statistics for active data guard. So as you can see, during the practice activity, you will create one topology, and also you will create a target catalog in the primary database, and then you will create database link to let London database to use the database link to ship AWR data to Boston database. And also when you go through here, I provided some information here, additional information. You will use DBMS UMF, Unified Management Framework. So you will have to go through lots of steps. I added all the the diagrams to give you a better understanding. And then finally you execute script. And after you set up AWR for Active Data Guard, and then you can execute DBMS workload repository that create remote snapshot. So you can take a snapshot. And then you can also create report, but not through Enterprise Manager as of now. As you can see, when you attempt to create AWR report from the London database, which is a physical standby database, instead of creating a report for physical standby database, it creates a report for the primary database. However, when you go through this step, you can create AWR report for both, in this case, the London database, and then you will have physical standby database AWR report. Since this report is available, you can also create ADDM report as well. Okay, so you can use the ADDM, but through the command line interface. In this the practice environment, you will go through steps in the topology demo topology for Boston and London database. This topology provides the AWR service, and then you can search for AWR report for physical standby database where Active Data Guard is enabled, and then you can create ADDM. So we use a DBMS ADDM analyze DB to create report. Finally, you will review report. So ADDM report is for, in this case, the London database. And also, through the top activity section or page of Enterprise Manager, we couldn't schedule SQL Tuning Advisor, but we have a way to do it. So we have using SQL Tuning Advisor for Active Data Guard instance. So creation of a tuning task is offloaded, and execution of a tuning task is offloaded, and we can also generate report. But changes made in the standby database must be written to primary database. So we have to have a database link. Okay, during the practice time, you will test this, so you will see how to use SQL Tuning Advisor. So throughout a short demonstration, I showed how to use Enterprise Manager for memory version of active session history, and also how to view performance information, and also how to view how to generate AWR report, and also how to use ADDM, and how to use SQL Tuning Advisor, and these are all short demos. And also you will perform hands-on practice activities. Analyzing report that's beyond the scope of this course, okay, because that requires a little bit of a knowledge, and also we have to apply analysis strategy. So this demonstration and this lesson mainly focused on how to use diagnostic tools for standby database, and especially active data guard standby database. So that's what I explained. So let's come back to a slide. Okay, so we have a quiz section. Enabling data guard network redo compression requires the Oracle database advanced compression option. The answer is true. And also maximum servers, apply servers, prepare servers parameters can be adjusted with the database initialization parameter file. The answer is false. It's not init parameter. It is in the setting of a DBMS package. And which diagnostic tools are available for active data guard instance? I showed in-memory active session history. I showed AWR. I showed ADDM. And I didn't show real-time SQL monitoring tool, but yes, this is also available to monitor long-running query in the physical standby database. So the answer is E. This is lesson 13. Practice 13-1, configuring network compression of redo data. In this practice, you will set the redo compression property to configure network compression of a redo. The first task is, in host 01, you log in as a sysdva. And you will check log archive dest to see redo compression has been enabled in any of the destinations. So everything is disabled. We haven't enabled the redo transport service with the compression. Now on host 02, you will get into data guard broker command line interface. And then you connect to Boston database. And we will enable read compression by editing far sync property. So edit far sync Boston set property read compression enabled. And return back to host 01. When you double check the log archive dest, the second destination, read compression is enabled in the second destination, which is a Boston far sync location. And also, when you display details of a log archive dest, and you will see same information. Show parameter log archive dest2. As you can see, this is to transfer redo to Boston file sync, and compression has been enabled. That's what we can confirm. In this practice activity, we practiced how to enable redo transport service with a compression. This is a practice 13-1. Practice 13-2, generating AWR report for an active data guard instance. In this practice, you will configure standby automatic workload repository. Starting with the Oracle Database 12.2, the automated workload repository or automatic workload repository can be configured to take snapshot of active data guard standby databases. This feature enables analyzing any performance-related issues for active data guard standby databases. The AWR framework is enhanced to support capture of remote snapshots from any generic database, including active data guard databases. This framework is called Remote Management Framework. So we're going to go through how to configure your data guard environment to capture the workload or snapshot from standby database. This practice will not include how to analyze AWR report for standby database. That's beyond the scope of this practice activity. In our environment, we're going to create RMF topology, which is a remote management framework. And we will use Boston database and London database. And in the Boston database, which is a primary database, we're going to configure target catalog to register Boston and London database as members of a topology, and then we will keep track of AWR data. This will require a long process, so I created a couple of scripts. So you can just simply review the scripts, and then finally you will execute final script. In order to use this feature, your standby database must be configured with the active data guard with a real-time query. So you will log in as SysDBA. Make sure you connect to London database, not London 2. And I will log in as SysDBA. And your open mode must be apply. Oops. That's a different one. The open mode must be the real-time query enabled. So currently it's a mount state. So in order to enable active data guard with a real-time query, you will have to open it first. And then you will have to open that one pluggable database. And then we're going to start MRP process. The time when you run alter database, recover, manage the standby database disconnect, probably the redo apply service is running before you run alter database command. So if that is the case, you will receive a message about that. Look at this. So MRP is already running. So finally, you will see that active data guard with a real-time query, open mode, read only with apply. So that's preparation. So preparation is done. Now you're gonna access to host 01, and you will set environment variable Boston, and then we're gonna review a few segments of a script. So the first the segment is awrs1 txt. At the end of this practice activity, we're gonna run a script. The first section of that script include several parameter settings used for the final script. So what is the primary database, in this case Boston, what is the standby database, and also what is the database link to be used, what is the topology name, and so on. In my case, this is just to review. I will just copy paste so you can also view as well. So I have the same information. And also, second text file, awr_s2. This will show you second section of the main script that will be executed at the end. This script is basically to configure AWR repository in the primary database. So the Boston database will be this framework, the repository. So we configure target catalog in the Boston database. So we're gonna use DBMS UMF package with a configure node. In the primary database, we're gonna configure target catalog. And also, third step is, this step shows how to make London Physical Standby Database as a source node of AWR data. So you have actually a target catalog, and we're gonna make the Physical Standby Database with the active data guard real-time query. This database is a source of AWR. So you can take remote AWR snapshot from Boston for London. So London is the source of the snapshot. So to do so, we're gonna use DBMS UMF package configure node. That's what we're gonna do. That's your source node. And also, finally, we can create the topology, remote management framework topology. So to do so, we have to use DMS UMF create topology. That's first step. And also, in this topology, we're gonna register node, so which is your Boston database as a member of this topology, and also London database as a member of this topology. So we're gonna register remote node. Here we have a DBMS UMF register node. In the topology, we're gonna register a standby database. Your primary database is the location where target catalog for AWR is reside in, so you don't have to register manually. That's implicit. And the next step is to register remote database in the target catalog to support remote AWR data. So we register the database as a member of RMF topology. We also have to register database to support remote snapshot. So we have to run DBMS workload repository and register remote database. So in the catalog, we have information about London database. So when as per the Boston database request, we can take a snapshot of London and save it in the target catalog location, which is a Boston database. And also, we have a verification step. So we have several the views available to display this topology information and member information and remote snapshot information. So you can quickly review it. So after you review a segment of a script, so that's actually segment of this script. So finally, you're gonna simply execute this script. So it does everything for you. So you will have to wait until it returns the prompt back. So if you are interested in, you will have to go through all this output, and then you have to wait until the OS prompt returned. So it's just still running. Finally, it's done. So as you can see, we have a target ID here. That is a number, and this is number. That's the final step. In the same terminal session connected to host share 1, and let's log in as a sysdva. And we can also create snapshot. This time we can use a create remote snapshot because we registered London database as a member of this topology. So when you go back here, we have a topology here, and also we have a DB ID. We registered this database, so we have all this information. So if you are interested in, you can go through here. In this topology, we have a Boston database registered and also London database registered. So we have this information. So let's create one snapshot from Boston database for London. So when you run this procedure, this request forwards to London database, and we take a snapshot through the database link. The Boston database will receive it. So we can execute. I think I have to execute. I don't know why it doesn't work. I will just execute this one more time. Control C. Execute. So what you're missing? Probably copy paste a problem. Okay, so now I can take a snapshot. I think in this case, these two lines are supposed to copy line by line. So copying two lines didn't work in my case. In order to create a report, and this we have to have a two snapshot, right? So we're gonna execute this one more time to have a two snapshots, so that way we can generate report. So we have two snapshots right now for London database. And I'm in the Boston database right now, so I'm in the host share 1. And then we're gonna generate AWR report for the London database. So we're gonna execute RDBMS admin, especially AWR RPTI script. And I'm looking for HTML type. And as you can see, we have two DB IDs registered. I'm not interested in Boston database, but I'm interested in London database. So you will have to copy DB ID of a DB ID of a London database. And also the instance number, since it is a standalone environment for single instance database, you enter 1 as the instance number. And number of days, I'm only interested in our last 24 hours in one day. So in the last 24 hours, we only took two snapshots. So for London database, we took a snapshot ID 1 and 2. So in order to generate report, we have to have two snapshots. One is the begin snapshot, and the other one is the end snapshot. So I will enter 1 as a begin snapshot and 2 as a end snapshot. And then what is your the report name? I will just provide default name and it will generate report. And done. So in order to view the report in HTML format, in our practice environment, what we will have to do is you're going to use a Tiger VNC viewer here, and we're going to navigate to host shadow 1 because we created report in host shadow 1. And then we will have to log in as Oracle. So select Oracle and password is Oracle. And then you can just open terminal from host shadow 1. And since we already know location and file name, so we're gonna start Firefox with this path and name. Or you can just manually open Firefox and then you navigate to the report location. As you can see, we were able to generate a physical standby database AWR report. Since it is only dummy report, the main purpose of this practice is to show you how to configure your data guard environment to support AWR report for London database. That was the only purpose. So that's why it doesn't include meaningful workload information. Elapsed time is only 0.5 minutes, and also DB time is 0.06 minutes. So after you practice this, if you are interested in your real environment, you can set up AWR report for your physical standby database, and then you can actually analyze it. But analyzing the AWR report, that's beyond the scope of this practice activity. So I'm going to close this browser. I don't need Tiger VNC viewer for host shadow 1. I closed it. And also come back to your host shadow 1 and host shadow 3 to exit out of SQL Plus. This is practice 13-2. Practice 13-3 using ADDM for an active data guard instance. In the previous activity, we practiced how to configure data guard environment to capture AWR snapshot for active data guard instance. Now, in this practice activity, we're going to practice how to analyze AWR snapshot statistics using ADDM. The first step is you get into host 01 and you set environment variable and you log in as a sysdba, and we're going to review the information on members and the topology which we created in the previous practice activity. So in the previous practice activity, we created one topology which called the topology demo, and we added 2 nodes, Boston and London, and also this topology to provide the AWR service. Now let's take a look at snapshot ID for the London database. The London database node ID is 16596700991. So as you can see, you have multiple snapshot IDs. Depending on how you did the practice activity, if you completed the previous practice activity the day before, you may have a many number of snapshot IDs. But if you completed the practice activity just right before, then you will have only 2 snapshots. And we're gonna use ADDM to analyze the workload in the last 2 remote snapshot period. So in this case, we're gonna use DBMS ADDM, analyze DB, but not for the current connected database, but this is for London database. From the previous, the query, we could identify a node ID of a London database. I'm gonna choose only first 2 snapshot IDs, just demonstration purpose. Now we're gonna run ADDM report. So basically we're gonna use a DBMS ADDM get report. Okay, so I was able to run ADDM to analyze workload in the 2 snapshots. You will have to set long and page size, and then you run report function. So this will give you information. So as you can see, analysis was requested for all instances, but ADDM analyzed instance London, meaning that this is for the London physical standby database. And ADDM detected your database was open in read-only mode, and it is in multi-tenant architecture. And since we didn't make any actual workload, there is no significant database activity and there is no problem. But in the real world, if you follow the same instructions in this practice activity, you can generate ADDM report and you will get some meaningful information. And then finally, you're going to exit out. This practice showed how to generate ADDM report for the remote database, which is physical standby database with the active data guard real-time query enabled. This is a practice 13-3. Practice 13-4 using SQL tuning advisor for an active data guard instance. In this practice activity, you will learn how to create SQL tuning task directly from physical standby database with the active data guard enabled. For this practice activity, one script has been executed to create part, supplier, and date dimension table and customers table and line orders table in OE schema. And OE schema exists in depth 1 pluggable database. So this is only a reference purpose, so do not execute it. Now you're going to get into host 01 and set environment variable, and we will have to log in as sysdba, but to depth 1 container or pluggable database. And then we're going to execute one simple script to delete optimize statistics. And later on, we're going to run problem query, and SQL tuning advisor will detect the missing optimize statistics. So for simple testing, we delete optimize statistics on reference to objects. And then we're going to connect to CDB root container. To prepare for SQL tuning advisor usage, you will have to create database link. Now this database link is used by the London physical standby database to connect to Boston database. Since the DDL change is not allowed in the standby database, we're going to run DDL statement in the primary database as a part of a preparation. Make sure you must be in the CDB root, not in the previous container. We're not going to create database link in the dep1 container. Instead, we will have to be in the CDB root to create database link. Okay, so I successfully created database link. Now I have to be in the host 03. Initially, you will be in the OS prompt, and then you will set environment variable. Make sure you set Oracle seed to London, not London 2. And then you will log in as a sysdba. Since we're going to run a problem query in the physical standby database, you must be in the dep1 pluggable database because all OE schema objects are reside in dep1 pluggable database. So you will have to run alter session set container equals to dep1 and also show pdbs. It's a read only. I'm going to run one simple problem query for simulation, and everyone will use the same SQL statement with the same SQL ID because we're going to run the script. And then you're going to find out SQL ID. Okay, so that's a SQL ID, AN7GRYGF86PRM. And then you're going to open new terminal window to create SQL tuning task in the physical standby database. So you will have to do SSH Oracle at host 03. And then set environment variable to London and log in as sysdba. You will create database link. You will create SQL tuning advisor in the CDB root container. But you have to make sure CDB root container can see SQL ID of a problem SQL statement. During the development of this practice activity, I noticed that there was some small delay. So sometimes, CDB root container doesn't see SQL statement executed in the pluggable database. So I will have to run this again. Okay, so in this case, the SQL ID is visible. So I can safely create SQL tuning advisor task. Okay, so let's see here. SQL ID AN7GRYGF86, it appeared, but SQL statement doesn't exist. Yeah, during the test, it happened a couple of times. So what you can do from the primary, from the host 03, where you executed the problem query, you execute one more time. and you verify one more time. Yes, it appeared here. And then you're going to execute task again. Okay, so this time it worked. So looks like in this version there may be some small delay between pluggable database and container database. So now what we're going to do, we're going to execute the SQL tuning task. So during the execution of a SQL tuning task, execution was done in the standby database. The analysis was done in the standby database. The result was written to primary database. So we offloaded SQL tuning task to standby database, except for writing the result. And then we're gonna the execute script to view the result of a SQL tuning task analysis. Okay, so we got the output here. As you can see, we have the output header here. This is a tune problem and also comprehensive. And this is to analyze this SQL statement. We found the two problems. So one is the statistics finding, table OE, date dimension was not analyzed, and also OE line orders was not analyzed. And then we have an execution plan of a SQL statement. So we have this information. So pretty much the same information that you used to get in the primary database, you can also run SQL Tuning Advisor for physical standby database to analyze problem SQL statement from the physical standby database. So as an option, what you can do, you go back to primary database, and then you're gonna the alter session to switch container to dep 1. Since the SQL Tuning Advisor recommended updating optimizer statistics as an option, you can execute DBMS procedure to update optimizer statistics. Okay, so why this size auto? Let me come back here. Let's see if I can copy directly from here or not. There is some formatting issue somewhere. So if you want, you can just type it. Execute dbms stat dot getter table stat, and owner name is OE, and table name maybe no space here, size auto. Yeah, this time it works. It looks like there is no space between columns and size. So I'm going to do the same thing here. Okay, it worked. So there was a spacing issue. Okay, so this is for practice 13-4.